Start with the basics. What exactly is an operating system or OS? At its core, an operating system is the software that manages all the hardware and software resources of a computer. It acts as an intermediary between users and the computer hardware, ensuring that everything runs smoothly. Without an OS, using a computer would be nearly impossible for most people, as you'd have to manually control every aspect of the machine. The OS handles everything from running applications to managing files and controlling peripherals like printers and keyboards. It's the foundation that makes modern computing possible. Operating systems perform several key functions that are essential for a computer's operation. These include managing hardware resources, providing a user interface, running applications, and ensuring security. The OS allocates memory, schedules tasks, and controls input and output devices. It also offers a platform for software developers to create applications that can run on different hardware. By handling these complex tasks, the OS allows users to focus on their work without worrying about the technical details of the hardware. One of the most visible aspects of an operating system is its user interface. This is how users interact with the computer, whether through graphical icons, menus, or command lines. Modern operating systems like Windows, macOS, and Linux offer intuitive graphical user interfaces, making it easy for users to navigate, open files, and run programs. The user interface is designed to be user-friendly, allowing people of all skill levels to operate computers efficiently. It's the bridge between the user and the complex inner workings of the machine. There are several types of operating systems, each designed for specific purposes. The most common are desktop operating systems like Windows, macOS, and Linux, which are used on personal computers. There are also mobile operating systems such as Android and iOS, which power smartphones and tablets. Additionally, there are server operating systems that manage network resources and embedded operating systems found in devices like smart TVs and cars. Each type is tailored to meet the needs of its environment. Desktop operating systems are designed for use on personal computers and laptops. They provide a full-featured environment for productivity, entertainment, and communication. Windows is the most widely used desktop OS, known for its compatibility and user-friendly interface. macOS, developed by Apple, is praised for its sleek design and seamless integration with other Apple devices. Linux, an open-source OS, is popular among developers and tech enthusiasts for its flexibility and security. Mobile operating systems are optimized for smartphones and tablets, focusing on touch interfaces and mobile connectivity. Android, developed by Google, is the most widely used mobile OS globally, offering customization and a vast app ecosystem. iOS, created by Apple, is known for its smooth performance and tight integration with Apple hardware. Both systems provide app stores, security features, and regular updates to enhance user experience. Server operating systems are designed to manage network resources and provide services to multiple users. Examples include Windows Server, Linux Server, and Unix. These systems are optimized for stability, security, and performance, often running without direct user interaction. They handle tasks like file sharing, web hosting, and database management, forming the backbone of business and internet infrastructure. Embedded operating systems are found in specialized devices such as smart TVs, cars, and home appliances. These systems are designed to be lightweight and efficient, often running on limited hardware. Examples include embedded Linux, VxWorks, and QNX. Embedded OSes are tailored for specific tasks, ensuring reliability and real-time performance in devices that require consistent operation. Critical function of any operating system is resource management. The OS allocates CPU time, memory, and storage to various programs and processes, ensuring that each gets the resources it needs without interfering with others. This balancing act is essential for system stability and performance. By managing resources efficiently, the OS prevents conflicts and maximizes the computer's capabilities. Process management is another core responsibility of the operating system. It involves creating, scheduling, and terminating processes, which are instances of running programs. The OS ensures that each process gets enough CPU time and that system resources are shared fairly. This coordination allows multiple applications to run simultaneously without crashing or slowing down the system. Memory management is crucial for the smooth operation of a computer. The operating system keeps track of each byte in the computer's memory and decides which process gets how much memory and when. It also handles swapping data between RAM and storage when necessary. Effective memory management prevents crashes and ensures that applications run efficiently, even when multiple programs are open. File management is another essential function of operating systems. The OS organizes files on storage devices, making it easy for users to create, delete, move, and access their data. It also manages permissions, ensuring that only authorized users can access certain files. This organization helps maintain data integrity and security, making file management a cornerstone of any OS. Device management involves controlling and coordinating the use of hardware devices such as printers, scanners, and external drives. The operating system uses device drivers to communicate with hardware, translating user commands into actions the device can perform. This ensures that all devices work together seamlessly, providing a smooth user experience. Security is a top priority for operating systems. The OS protects data and resources from unauthorized access through user authentication, permissions, and encryption. It also guards against malware and other threats by providing regular updates and security patches. By implementing these measures, the OS helps keep your information safe and your computer secure. Modern operating systems are equipped with networking capabilities, allowing computers to connect to local networks and the internet. The OS manages network connections, data transfer, and communication between devices. It also provides tools for configuring network settings and troubleshooting connectivity issues. Networking features are essential for sharing resources and accessing information online. Multitasking is the ability of an operating system to run multiple applications at the same time. The OS allocates resources and schedules tasks so that users can switch between programs seamlessly. This feature boosts productivity and allows for a more dynamic computing experience. Whether you're browsing the web while listening to music or editing documents, multitasking makes it possible. Operating systems support multiple user accounts, allowing different people to use the same computer while keeping their data and settings separate. Each user can have personalized preferences, files, and access permissions. This feature is especially useful in shared environments like offices and schools, ensuring privacy and security for all users. Regular system updates are crucial for maintaining the security and performance of an operating system. Updates often include bug fixes, new features, and security patches that protect against emerging threats. Most modern OSes offer automatic updates, ensuring that your system stays up to date with minimal effort. Operating system provides a platform for running applications from word processors to games. It manages the installation, execution, and removal of software, ensuring compatibility and stability. The OS also offers application programming interfaces, APIs that developers use to create new programs, expanding the system's capabilities. Most operating systems allow users to customize their experience. You can change themes, adjust settings, and install extensions or widgets to personalize your desktop. Customization options help users create a comfortable and efficient working environment tailored to their preferences. Operating systems include tools for monitoring system performance, such as task managers and resource monitors. These tools help users track CPU, memory, and disk usage, identify bottlenecks, and troubleshoot issues. Performance monitoring is essential for maintaining a healthy and responsive system. Backup and recovery features are built into most operating systems to protect against data loss. Users can create backups of important files and restore them in case of hardware failure or accidental deletion. These tools provide peace of mind and help ensure that valuable data is never lost. Accessibility features in operating systems make computers usable for people with disabilities. These include screen readers, magnifiers, voice commands, and customizable input methods. By offering these tools, the OS ensures that everyone can benefit from technology, regardless of their physical abilities. Virtualization is a feature that allows one physical computer to run multiple virtual machines, each with its own operating system. This is useful for testing, development, and running different environments on the same hardware. The OS manages these virtual machines, allocating resources and ensuring isolation between them. While most users interact with operating systems through graphical interfaces, many OSes also offer a command line interface, CLI. The CLI allows advanced users to execute commands directly, automate tasks, and access powerful system functions. It's a valuable tool for administrators and power users who need greater control over the system. Graphical user interface GUI is what most people use to interact with their operating system. GUIs use windows, icons, menus, and pointers to make navigation intuitive. This visual approach simplifies complex tasks and makes computers accessible to a wider audience from beginners to experts. Operating systems can be open source or proprietary. Open source OSes like Linux allow users to view and modify the source code, fostering innovation and customization. Proprietary systems like Windows and macOS are closed source, offering polished experiences but less flexibility. Each approach has its advantages depending on user needs and preferences. Some of the most popular operating systems include Microsoft Windows, Apple macOS, Linux distributions like Ubuntu, Google Android, and Apple iOS. Each has its unique features, strengths, and user base. Understanding these examples helps you appreciate the diversity and evolution of operating systems over time. History of operating systems dates back to the early days of computing. Early computers required manual operation, but the development of batch processing and time-sharing systems revolutionized the field. Over the decades, OSes have evolved from simple command line interfaces to sophisticated graphical environments, shaping the way we use technology today. Future of operating systems is shaped by emerging technologies like cloud computing, artificial intelligence, and the Internet of Things (IoT). OSes are becoming more adaptive, secure, and interconnected, supporting new devices and smarter automation. Staying informed about these trends helps users and professionals prepare for the next wave of innovation. Cloud-based operating systems are designed to run applications and store data on remote servers rather than local devices. Examples include Chrome OS and some enterprise solutions. These systems offer flexibility, scalability, and easy access from anywhere with an internet connection, making them ideal for modern, mobile workforces. Real-time operating systems, RTOS, are used in environments where timely processing is critical, such as medical devices, industrial machines, and robotics. RTOSs guarantee that tasks are completed within strict time constraints, ensuring reliability and safety in mission-critical applications. Mobile and desktop operating systems are designed with different priorities. Mobile OSes focus on touch interfaces, battery efficiency, and connectivity, while desktop OSes prioritize multitasking, performance, and compatibility with a wide range of hardware. Understanding these differences helps users choose the right device for their needs. Kernel is the core component of an operating system. It manages communication between hardware and software, handles resource allocation, and enforces security. There are different types of kernels, such as monolithic and microkernels, each with its own design philosophy. The kernel's efficiency directly impacts system performance and stability. Vice drivers are specialized programs that allow the operating system to communicate with hardware components. Without drivers, the OS wouldn't be able to use devices like printers, graphics cards, or network adapters. Manufacturers regularly update drivers to improve compatibility and performance, making them a vital part of the OS ecosystem. Boot process is how a computer starts up and loads the operating system. When you power on your device, the system firmware initializes hardware and loads the OS kernel into memory. The OS then takes over, starting essential services and preparing the system for use. A smooth boot process is critical for reliability and user experience. System services are background processes that support the core functions of the operating system. These include managing print jobs, handling network requests, and updating software. Services run quietly in the background, ensuring that the system operates smoothly and efficiently without user intervention. Task scheduling is how the operating system decides which processes get CPU time and in what order. Efficient scheduling ensures that all applications run smoothly and that system resources are used effectively. Different OSes use various algorithms to optimize performance and responsiveness. Interprocess communication (IPC) allows different processes to exchange data and coordinate actions. The operating system provides mechanisms like pipes, message queues, and shared memory to facilitate IPC. This is essential for complex applications that rely on multiple processes working together. System calls are the interface between user applications and the operating system. When a program needs to perform a privileged operation like accessing hardware or managing files, it makes a system call. The OS then checks permissions and executes the request, maintaining security and stability. File system is the method an operating system uses to organize and store files on a disk. Common file systems include NTFS, FAT32, and ext4. The choice of file system affects performance, compatibility, and security. Understanding file systems helps users manage data more effectively. Power management features in operating systems help conserve energy and extend battery life, especially on laptops and mobile devices. The OS can adjust hardware settings, dim screens, and put devices to sleep when not in use. These features are essential for portable computing and environmental sustainability. Localization allows operating systems to support multiple languages and regional settings. Users can choose their preferred language, date formats, and keyboard layouts. This makes computers accessible to people around the world and ensures a comfortable user experience regardless of location. Mobile operating systems include specialized security features to protect against threats like malware, phishing, and unauthorized access. Features such as biometric authentication, app permissions, and encrypted storage help keep user data safe on smartphones and tablets. In summary, operating systems are the backbone of modern computing, enabling users to interact with hardware, run applications, and stay secure. From desktops to mobile devices and embedded systems, OSes play a vital role in our digital lives. Understanding their functions and features helps us make informed choices and use technology more effectively.